students. So today we will discuss about the memory errors and detection of errors and correction of errors. Okay, so memory errors. So up to now we have seen that is we are going to store the memory. We are going to store the data into memory locations. We are thinking that the stored data will be as it is. Whatever we are written data, that will be as it is. Whenever we are going to read that data, that you will get the original data as it is, but it is not like that. So there will be some errors will be occurred into the stored data, that some of the bits in the memory can be flipped, okay, and you will get the wrong data. Then how to check that, and what are the different types of errors, how to correct that errors, that we will see here. Okay, so there are two types of errors. One is a hard error and another is a soft error. Hard error and soft error. Hard errors are it is due to the chip is broken. That is, these errors are due to the manufacturing defects or due to the prolonged use. That is, memory is wear out. Okay, so this is permanent error. We can't change it. Okay, so whenever we can rewrite it, also the damaged cells, they are not going to able to correct it. Okay, and hence this type of errors are permanent errors, and hence the name is given hard errors. Another type of errors are called as a soft errors. Soft errors are due to the change into due to the corrupted data. Okay, or these errors are occurred due to the highly charged particles, that is neutrons, are bombarded onto the silicon atoms. That is highly charged cosmic rays, that is from atmospheric neutrons, they will collide onto the silicon atom, and the flips are going to flip the some of the bits. Okay, and that bits cause the error. So now these errors are depending upon the how, in which area the memory is working, and in which atmosphere the memory is produced. So depending upon that, the frequency of errors is going to be occur. But these errors are temporary, then, and these errors can be changed when we rewrite it. These errors we can correct it. Okay, so these errors are the soft errors. When we can rewrite it, then we will get, or we can restore the data. Okay, so these errors are caused due to the flipping of bits, and it is due to the atmospheric neutrons. Okay, so then how we can detect the error is occurred or not. Okay, so error detection is by using parity bit. Okay, you know that a parity, so there are two types of parity. One is odd parity and another is even parity. Okay, that is, we have to add extra bit along with the data bit. Okay, on right axis, whenever we are going to store the data, at the time one more bit we need to add, that is according to the parity of the bit. Okay, so we have to add that extra bit and we have to write it. Compute parity, either it may be odd parity or it may be even parity, and then we have to store it with the data bit. On read axis, we check the parity and we will check, or we will take the data without the parity bit. Okay, but you will get, we can detect whether the error is occurred or not. See here one simple example, that is 4-bit data. Here it is 1101, and one extra bit added here, that is called as parity, and that is for odd parity. See, there is a even number of odd number of ones, 2 and 3 number of 1, hence the odd parity is set. So we have stored the data. Now by means of any change, this bit is flipped from 1 to 0. Now even you can see here, if we read the data and if we check what is the parity, now you will get the even parity. But here this is for odd parity, it is 1, and hence so we can see that data one of the error is occurred, and so instead of odd parity we got even parity, and hence so error can be detected. But if we could tell which bit is flipped, so we can't able to change, we can't able to say that which bit, this bit is flipped, this bit flipped, this flipped. So we can't tell that which bit is flipped. Okay, and correction by how we can correct, we don't know which bit is flipped and then we can't correct it. Okay, so therefore it is very difficult to detect the error and correct the error by using parity bit. Okay, so then next, how to correct, how to detect the error and how to correct the error. So to detect the error, so we have to use error correcting code. That is error correcting codes, that is nothing but the Hamming codes. So this ECC, error correcting codes, allows identification of the flipped bit. Which bit is changed, it will tell us. Okay, so for example, we'll start with the single bit error correcting code. We'll start with the single bit error correcting code. So now let us take, that is, there is n bit data word or n bit word we want to store into the memory. Now into this n bit we need to add parity bits or we need to add check bits. Then how to calculate how many number of the check bits will be there? So for n bit data word or for n bit word, so how many bits we need to add? So log n to the base 2 plus 1 extra bit we need to add, that is we need to add the log n plus 1 are the check bits we need to add. For example, 8 bit data word is there, so D1 to D8 are the data bits. Okay, so therefore if you take log n to the base 2 log of 8 to the base 2, so you will get the 3 will be it. 3 plus 1 is equal to 4, so we required 4 data bits. The 4 are the check bits. Okay, so these 4 check bits you will get. Now data bits are the 8 bits and check bits are 4 check bits. So therefore total number of ECC will be 12 bit ECC will get. 8 are the data bits and these are the check bits. Now we got the 4 number of check bits. Then how to calculate this 4 number of check bits and where we have to place this 4 number of bits? Now see, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3 and so on. Likewise we need to add this number of, we need to place this error correcting error and these check bits. Okay, the position of the check bit is 2 raised to 0, 2 raised to 0 is 2 raised to 0 is 1, so E1 is the 1 check bit. 2 raised to 1 is 2, that is another check bit. Then 2 raised to 2 is nothing but the 4, so this is 4 is the another check bit. 2 raised to 3 is the another check bits. Now you got, that is we required 4 check bits and the position of the check bit is 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. So therefore E1, E2, E4 and E8 are the check bits, and remaining will be the data bits. So see here, so E1 is the check bit, E2 is the check bit, E3 is the D1, E4 is the check bit, E5 is D2, E6 is D3, E7 is D4, E8 is the another check bit, E9 is D5, E10 is D6, E11 is D7 and E12 is D8. In this way we can form a error correcting code. Okay, now what are the values, how we can calculate what is the value of E1, what is the value of E2, what is the value of E4, how to calculate these check bits. These check bits are calculated from data bit itself. Okay, now we'll see how to calculate these bits. Now see here, these are the data bits and these are the check bits E1, E2, E4 and E8. Okay, so we know that. Now what are the positions? That is 2 raised to 0, 2 raised to 1, 2 raised to 1, 2 raised to 2, 2 raised to 3. These are the positions E1, E2, E4 and E8. Now how to calculate E1, E2, E4 and E8. So to calculate E1, so let us say that is E1 is nothing but the 0 0 0 1, E2 is equal to 0 0 1 0, E3 is equal to 0 0 1 1. So likewise we can proceed from E1, E2, E3, E4 up to E12. We are simply applying the binary number for each code word or binary number for each E1 to E12. Okay, so that is 0 0 0 1. Likewise 0 0 1 0, 0 0 1 1. And now how to calculate this E1? So to calculate E1, come for the first column and leave the first position and go in downward direction and see whether the positions of 1. So collect all the terms of having even one number. Okay, so therefore for first column and leave the first position and collect all the terms having 1. So that is E3, okay, E3, E5, E7, E9 and E11. Let us XOR these bits to get E1. So E1 is equal to E3 XOR E5 XOR E7 XOR E9 XOR E11. See here, E1 is equal to E3 XOR E5 XOR E7 XOR E9 XOR E11. In this way we can calculate E1. Now how to calculate E2? E2 can be calculated. Now go for the second row and leave this second position and from downward direction where we will get 1, that number of that positions of bits we have to collect together and we have to make XOR of them. So now for E2, so E3, E6, E7, E10, E11, these bits we have to collect and we have to XOR them. So therefore E2 is equal to E3 XOR E6 XOR E7 XOR E10 XOR E11. Okay, so likewise we can calculate E4. E4 is equal to, now go for third row, and that E4 is equal to, now leave the fourth position, okay, and go downward direction, where you will get 1, where you will get 1, that positions, that terms we have to collect together. So for E4, so E5, E6, E7 and E12. See here, E5 XOR E6 XOR E7 XOR E12. So we have to collect these bits, we have to XOR these, so that you will get the E4. Okay, E4 is equal to E5 XOR E6 XOR E7 XOR E12. And then E8 is equal to E8 is equal to E8 is equal to go for the 8th position, leave that 8th position and go in downward direction, where you will get 1, collect all the terms, that therefore E9 XOR E10 XOR E11 XOR E12. Now E8 is equal to E9 XOR E10 XOR E11 XOR E12. Okay, so in this way we can write the ECC word. So ECC word for 8-bit data word, so you will get the 12-bit ECC word. Out of that you will get the 4 number of the 4 are the check bits, and the 4 are the check bits like E3, E5, E1, E2, E5, E4 and E8 are the check bits, and remaining are the data bits. And in this way we can calculate these check bits. Okay, so this is about how to write the check bit, how to write the error correcting code. Now we will go how to, or we will see how to calculate, how to correct, how to detect the error and how to correct the error. Now first read the check bits. So from the ECC word you read the check bits. Okay, then from the received data, from the received error, from the received data bits, that is from received ECC word, you can once again recompute the check bits. So whatever you are getting, that check bits from the directly reading the data, and you calculate the check bits from the available data bits. Okay, then XOR them with each other, XOR them with each other. Then what if the result, if result, so that result is called as a syndrome. If the syndrome, so syndrome is the whatever the check bits we have calculated from the data bits, and we have to calculate, we have to read the check bits and we have to calculate the check bits, and then we have to take XOR of this bitwise XOR, and then we will see if this result is called as a syndrome, and syndrome is equal to 0 0 0, then there is a no error will be occurred. If data bits are flipped, then you will get the sum syndrome. Okay, then that syndrome is nothing but that number of bit is a flipped, and you can correct that bit. Okay, you will, so error will be detected and you have to correct directly that bit by flipping once again, so that you can correct the error. So on error, flip the bit and rewrite the memory location, so that the error will be corrected one. Now with the help of one example we can see how to write the ECC word, and then we'll take one more example to how to detect and correct the ECC word. Okay, let us take example in your book, that is 5.11, example number 5.11. Calculate or compute the 12-bit ECC word from corresponding to the 8-bit data word. 8-bit data word is given here 0110, 000 and 1. Okay, 0110, 000, 1. So this is data bit. Now for this data bit we know that, so 8-bit is the data bit. So log n to the base 2 plus 1 are the check bits, so that you will get for 8-bit data word you will get the 4 number of check bits. So number of check bits having position is equal to e1, e2, e4 and e8. These are the check bits and remaining are the data bits. So these are the data bits. We have to directly place, that is 1 here. So that is a d1, this d1. So d2, this d2, this d3, this d3, d4, this d4, d5 at here, d9 is at here, d okay d okay see here, d4, d5 will be at here, then d6 will be at here, d7 will be at here, and d8 will be at here. In this way we can place the all the number of bits. Now how to calculate this e1, e2, e4 and e8 we need to calculate. So e1 is calculated as so we have seen in previous slide how to calculate e1. E1 is the XOR of e3, e5, e6, e9 and e11. So e3 is nothing but d1, then d2, d4, d5 and d7. All these bits we have to make XOR. So this 1 XOR 0, XOR 0, XOR 0, XOR 0. So there are even number of ones, means you will get XOR is equal to 0. Okay. So now e2 is equal to e3, e6, e7, e10 and e11 XOR all of this, then that is 1 0 0 1 1, all this XOR 1 XOR 0 1 0 XOR 0 XOR 1 XOR 1. Okay, so that 1 2 and 3 number of zeros are there, and hence 3 number of ones are there, means XOR you will get 1. So likewise e4 is equal to e5 XOR e6 XOR e7 XOR e2. Okay, so d2 XOR d3 XOR d4 XOR d8, and that is equal to 0 XOR 0 XOR 0 XOR 0 is equal to 0, and e8 is equal to e9 XOR e10 XOR e11 XOR e12. So that is nothing but d5, d6, d7 and d8. So XOR of all this, that is 0 1 1 and 0, again you will get a 0. Now put these values into respective memory locations. So we have to put this is equal to 0, this is equal to 1, so at 1, and this is equal to at 4th place, and this is we have to write e8 at the 8th place. Okay, and in this way you will get the ECC word is equal to this, that is 1 0 double 1 0, again 4 0 and 0 1 1 0. Okay, so this is about how to write ECC word. Now we have stored the data and we are going to check whether the error is occurred or not, and if error is occurred, then how to detect that error and how to correct that error we can see by using this example. So example number 5 and 13. So determine whether there is an error in the ECC word. So ECC word is given 0 0 0, that is 0 0 1 1 0 0 1 0 0. If error is occurred, if so, correct it. If error is occurred, we have to correct it. Now, so first step is that we have to write the check bits, or we have to write the check bits up. We have to read the check bits. So this is 0 0 and this 0 and 8th position. So this is the 8th position. Okay, so 1 0 0 0, this is the check bits. Now again we have to calculate the check bits from whatever the equation we have studied. E1 is equal to E3 XOR E5 XOR E7 XOR E9 XOR E11. Now we have to check this. Okay, so 1 0, so see here, what is E3? E3 is equal to 1. Likewise, what is E5? E5 is equal to this 0. What is E7? E7 is equal to 1. So here, and likewise we can place this all the values and we'll get E1 is equal to 1. Now again E2, calculate E2. E2 is equal to E3 XOR E6 XOR E7 XOR E11 XOR E10 XOR E11, and put these values of 1 0 1. Okay, 1 0 0. Okay, so now again you will get this XOR will be answer is equal to 0. So likewise E4 is equal to E5 XOR E6 XOR E7 XOR E12. So 0 0 1 0, and you will get the XOR is equal to 1. Now E8 is equal to E9 XOR E12, E10 XOR E11 XOR E12. So therefore 0, see here, so this is, so E9, so this is E9 E9 E10 E10 E11 and E12, 9 10 11 12. So that is, you will get all these values. So that is 9 10 11 and 12, that is equal to XOR is equal to 1. Okay, now how to calculate syndrome? Now we have to check this. So again once we have to write what is the check bits 1 1 0 1. So we have read already check bits is equal to 1 0 0 0. Now we have to make XOR of these two so that you will get the syndrome. So we have calculated check bits are 1 1 0 1. Calculate check bits are 1 1 0 1. Read upward direction. Okay, so syndrome is equal to 1 1 0 1, and one more, another check bits are 1 0 0 0. So that is, so this check bit, so XOR of these two, so that make the bitwise XOR operation, that is 0 and 0, you will get 1 1 and 0. So 0 0 0 and 1 0 1 you will get, and 1 1 will get the 0. So there, thus there is an error. So these bits are not 0, and hence there is error is occurred. So we have detected error. Then which bit is having error? So that is, so this is directly, the syndrome is directly given the number of bit. Which bit? So 0 1 0 1 is nothing but the 5. So fifth bit is having error. Fifth bit of ECC is having error. Now that bit we need to flip it so that we can correct it. So fifth bit, you can see here, fifth bit 0 1 2 3 4 5. So this is 0. So we have to change from 0 to 1. So we have to make it 0 to 8. So that bit is flipped back from 0 to 1, giving the corrected word. Now the word is corrected. Now the corrected ECC word is written here. Corrected ECC word is equal to this. Only we have to flip this bit, fifth bit we have flipped, and we get the corrected word. Okay, in this way we can check the error, and we can detect the error, and we can correct the error. So I think you will get this example, and today we'll stop here. Thank you.